Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. IP addressing is at the heart of every communication on a network. Whether a user is browsing the web, sending an email, or accessing a shared printer, data must be directed from source to destination, and that path is made possible by IP addresses. IP addressing provides a logical structure for identifying devices, enabling routers to forward packets accurately across local networks and the global internet. It defines the boundaries between networks, isolates traffic, and ensures that communication flows efficiently and securely. Without a sound grasp of how IP addressing works, no network can be properly understood or maintained. For students preparing for the Network Plus certification, IP addressing and subnetting represent some of the most important topics on the exam. These subjects are tested heavily through calculation-based questions, scenario analysis, and practical application. You may be required to determine how many usable addresses exist in a subnet, identify a network's broadcast address, or choose the correct subnet mask for a particular network size. These questions test both conceptual understanding and numerical accuracy, and success depends on developing fluency in both. An IP address is a logical identifier assigned to every device that participates in a network. It tells routers and switches where a device lives within the overall structure of the internet or a local network. Unlike MAC addresses, which are fixed to hardware, IP addresses are assigned through software and can be changed based on network design. Each IP address includes two portions: the network portion, which identifies the subnet, and the host portion, which identifies the individual device within that subnet. This dual structure makes it possible to both organize devices and route traffic intelligently. IPv4 addresses are 32-bit binary numbers that are typically expressed in dotted decimal format. These 32 bits are divided into four 8-bit groups called octets. Each octet is translated from binary to decimal and separated by periods. This binary foundation is important when calculating subnets or performing address conversions. While most users never see or work with the binary version, network professionals must understand it to design subnets, calculate address ranges, and troubleshoot addressing issues. Subnetting is the process of dividing a larger IP network into smaller, more manageable subnetworks. Subnetting allows network administrators to control broadcast traffic, isolate devices by function or department, and make more efficient use of IP address space. Subnetting is defined through the use of subnet masks or prefix lengths, which dictate how many bits of the address are used for the network and how many are reserved for hosts. Subnetting is essential in both IPv4 and IPv6, though the methods differ slightly between the two protocols. A subnet mask separates the network portion of the IP address from the host portion. It's written in the same dotted decimal format as IP addresses and defines which bits of the IP address represent the network. In binary, the first 24 bits are network bits. The remaining 8 bits are available for host addresses. Subnet masks help routers and switches determine whether a destination IP address is within the same network or needs to be forwarded elsewhere. CIDR, or classless interdomain routing, introduced a shorthand for representing subnet masks using a slash notation. Instead of writing out 255, 255, 255.0, for example, you can use /24 to indicate that the first 24 bits of the address are for the network portion. This notation is compact, easier to work with, and is now used almost universally in routing tables and configuration files. CIDR also allows for more granular subnetting compared to the older class-based system, where subnet sizes were fixed based on IP address ranges. Historically, IP addresses were divided into classes: Class A, Class B, and Class C, based on the leading bits in the address and their default subnet sizes. Class A networks used a default subnet mask of 250.50.0.0. Class B used 250.525, and Class C used 250.525.255. To find out why that is, listen to Episode 4. These classes were useful in early IP deployment, but they wasted address space and limited flexibility. CIDR replaced the class-based system in the mid-1990s, allowing for more efficient allocation of address space and the creation of variable-sized subnets. Private IP address ranges are reserved blocks of addresses set aside for use within internal networks. These addresses are not routable on the public internet and are meant for use inside homes, businesses, and organizations. The private address ranges are 10.0.0.0 to 10.2.125 to 215.5, to 10.55 to 255 for Class A, 172.16.00 to 172.31, 255, 265 for Class B, and 192, 168, 255 for Class C. These ranges allow organizations to use internal IP addresses freely without interfering with public internet traffic. Routers use NAT to translate these private addresses when devices need to access the internet. Understanding the difference between public and private IP addresses is essential for designing secure and functional networks. Public IP addresses are assigned by ISPs and are globally unique. These addresses are used on internet-facing devices such as web servers, email servers, and home routers. Private IP addresses, by contrast, are used internally and must be translated via NAT to access external service. Mixing public and private addresses improperly can cause connectivity problems and security risks. NAT devices sit at the edge of private networks, managing the translation between address types and enabling multiple internal devices to share a single public IP. Address calculation is an important skill in both certification exams and real-world networking. You must be able to calculate the number of available hosts in a given subnet, determine the range of valid IP addresses within that subnet, and identify the subnet's network and broadcast addresses. For example, in a /24 subnet, 255, 255, 255, 255, 255, 255, 255, there are 256 total addresses. The first is reserved as the network address and the last as the broadcast address, leaving 254 usable IPs. These calculations become more complex as subnet sizes vary, especially when performing variable length, subnet masking, VLSM, or summarization for routing. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. To effectively plan and manage IP addressing, network administrators rely on a variety of tools and techniques that simplify calculations and reduce the likelihood of error. Subnet calculators are among the most useful resources, allowing you to input an IP address and subnet mask or prefix length and receive key details such as the number of hosts, broadcast address, and valid host range. Many of these tools are available online or built into network configuration utilities. Additionally, converting between binary and decimal is an essential skill when working with subnet masks or troubleshooting address issues, and reference charts can aid in quickly identifying common subnet lengths like /24, /30, or /28. Subnet sizes are tailored to different types of connections and network segments. A /30 subnet, which provides two usable IP addresses, is typically used for point-to-point links between routers where only two hosts need to communicate. A /24 subnet, offering 254 usable addresses, is often used for standard LAN segments such as office floors, VLANs, or departmental network. Larger networks that require more hosts might use a /16 subnet, allowing over 65,000 devices within the same address space. Selecting the correct subnet size balances efficiency, broadcast control, and address conservation. Subnetting has a direct impact on routing. When networks are divided into subnets, routers must keep track of each subnet individually. However, proper subnetting allows administrators to summarize routes and reduce the size of routing tables. This process, known as route aggregation, improves routing efficiency and reduces CPU load on network devices. Additionally, subnetting allows administrators to design networks with greater control over traffic flow. For example, a subnet might be isolated from others for security reasons, or to contain broadcast traffic, within a specific department or application group. There are several compelling reasons to subnet a network beyond simply managing IP addresses. Subnetting helps improve performance by limiting the size of broadcast domains. Smaller subnets mean fewer devices per segment, reducing the amount of broadcast traffic each device must process. Subnetting also enhances security by enabling isolation between departments or systems. For instance, accounting may have its own subnet with access restricted to sensitive resources. From an organizational perspective, subnetting allows logical grouping of systems by function, department, or location, which simplifies network management and documentation. Variable length subnet masking, or VLSM, allows different subnet sizes to coexist within the same network architecture. This approach conserves IP address space by allocating only as many addresses as are needed for each subnet. For example, a point-to-point link may only require 2 usable IPs, so assigning a /30 subnet avoids wasting addresses. Meanwhile, a core switch with hundreds of connected devices may use a /23 or larger subnet. VLSM also supports hierarchical routing, where subnets are grouped into larger address blocks that can be summarized in routing tables, improving efficiency and scalability. IP address planning is a critical discipline for building scalable and manageable networks. Planning begins with identifying how many subnets are needed and how many hosts each subnet must support. Administrators should document all assigned IP addresses, define IP ranges for static and dynamic use, and reserve address space for growth or future technologies. Planning also includes avoiding overlapping subnets, which can lead to routing conflicts and access issues. Proper documentation includes spreadsheets, diagrams, and configuration notes that can be referenced during audits, expansions, or troubleshooting efforts. Even with planning, IP addressing errors are common and can have significant consequences. One of the most frequent mistakes is using the wrong subnet mask, which can result in unreachable hosts or incorrect routing. Another issue is overlapping subnets, where 2 networks share some portion of the same address range, leading to unpredictable behavior. Duplicate IP addresses are another problem, often caused by misconfigured static addresses or DHCP pool mismanagement. These conflicts can cause intermittent connectivity issues, login failures, or disrupted services. Troubleshooting tools such as ping, tracerroute, and IP scanning utilities can help identify and resolve these problems. Expect a wide range of addressing questions on the Network Plus exam. These may include direct calculation questions, such as determining the number of usable hosts in a subnet or identifying the broadcast address for a given network. Scenario-based questions may present a network layout and require you to choose the correct subnet size for a department or to identify errors in address assignment. Questions about public and private IP addresses are also common, requiring you to differentiate between internal and internet routable addresses and to recognize when NAT is needed. You may also be asked to interpret CIDR notation and determine the subnet mask it represents, for instance, recognizing that a /26 subnet mask corresponds to 255, 255, 255, 192, and supports 62 usable host addresses. Other questions may involve matching IP address ranges to private or public categories, or identifying which subnet a given IP address belongs to. These questions require a mix of math, memorization, and contextual understanding, all skills that come with regular practice and study. In real-world network design, understanding addressing and subnetting is essential for creating resilient, efficient, and secure networks. IP addressing defines how data moves between devices and how resources are accessed. Subnetting allows you to contain problems, optimize performance, and design networks that can grow alongside the organization. Without careful subnet planning and management, networks become harder to maintain, more prone to outages, and more vulnerable to misconfiguration. Mastering these concepts equips you to design networks that are both robust and future-ready. In summary, IP addressing and subnetting form the logical framework of network communication. An IP address identifies each device, while subnetting defines the boundaries that shape traffic flow and device grouping. From CIDR notation and subnet masks to private addressing and variable length planning, these tools allow administrators to build intelligent, Structured networks. Whether you're sitting for the Network Plus exam or designing your next infrastructure rollout, a solid foundation in addressing and subnetting is essential for navigating the complexities of modern networking with confidence. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.